welcome back to my video. My name is Asima Sulys Simanjuntak. My ID number 4193111045. I'm a college student from Mathematics Education Study Program 2019 at State University of Medan. Now, I want to explain about the chapter 12. It's about Europe mathematics development. First, I want to explain about mathematics research in Europe. Based on classical research, European mathematics came from Thales and Euclid. The Greeks studied, critiqued, and spread by Arab Muslims in the early Middle Ages, and then in the 12th and 13th centuries, AD was used by Europeans. Algebra emerged from the practice of algebra by abacus, disseminated by its user by Fibonacci and Pacioli. The practice of problem-solving algebra in this tradition developed from Islamic Arab sources. The epistemic basis of mathematics as a calculation was formed by the Arab Islamic world. An explanation of this basic became the main motivation of our analysis of the basic concept of Islamic Arabic algebra in the beginning. And next, number 2. Progression of future in Europe. Around the year 825, a Persian mathematician named Al-Khwarizmi wrote a book on algebra which, among other things, contains the complete Hindu number system. Later, this book was translated into Latin in the 12th century, and his books were influential in Europe. It was this translation that introduced the Hindu-Arabic number system to Europe. Next, number 3. The development of mathematics in Europe in the 13th until 16th century. The first 13th century. In the 13th century appeared a figure named Leonardo Fibonacci. Leonardo Fibonacci, or better known as Leonardo da Pisa, was the most talented mathematician in the Middle Ages. He was the son of a merchant who followed his father to trade to Egypt, Sicily, Greece, and Syria. His greatest work was a book entitled Liber Abensi in 1202. This book deals with problems using Hindu-Arabic symbol, which show that he was influenced by the algebra of Al-Khwarizmi and Abu Kamil. Number 2, 14th century. The 14th century was a barren period for mathematics. This is the century of the Black Death that wiped out more than 1/3 of the population of Europe. In this century, there was a 100 Years' War, with political and economic turmoil in Northern Europe at its peak. Although medieval mathematics was essentially practical, speculative mathematics didn't completely disappear. The ideas of scholastic philosophers led to subtle theoretical truths about motion, infinity, and continuity, all of which are central to modern mathematics. Number 3, 15th century or Renaissance period. In history, the 15th century is called the Renaissance era, namely the rebirth of attention to classical Roman and Greek culture and trying to find new value from this culture. In the 15th century, printing equipment was also found, so that the trade in science book also developed. Mathematical activities in the 15th century were centered in Italy, in Nuremberg, Vienna, and Prague. In the book Trigonometry, he wrote 3 conditions to be able to determine the elements of a triangle. For example, determine the elements of a triangle. If one side is specific, the height on that side and the ratio of the other 2 sides. Solving this problem, he still uses rhetorical algebra. He also wrote the tangent function table. And then next for the 16th century, there are first towards algebra with symbol Robert records word works in algebra, geometry and astronomy. In 1557, he wrote algebra with the title The Whetstone of the Wheaton. It was in this book that symbol equals was the first use for similarity as it used today. Michael Stiefel, a German monk, published a book entitled Arithmetica Integra in 1553. In that book, he described irrational numbers, arithmetic series, geometric series, binomial coefficient to the seventh power. The book used the symbol plus and minus as arithmetic operation and used letter for the unknown. And the next, number 2, algebra using letters. Francois Fit was born in Fontenay. He was a jurist and member of parliament, but with extraordinary talent used his spare time studying mathematics. Even then, he was seen as the greatest mathematician of AD 16th. He wrote a trigonometry book with the title Canon Mathematicus Seu et Triangula. This book was the first on Europe to systematically solve plane and spherical trigonometry problems. Number 3, high equation. In 1600, Descartes wrote algebra under the title De Numerosa Potestatum Resolution. In the book, he described the approximation of the roots of high-degree equations successfully. The fifth method was used in Europe until 1680. Number 4, ending the 16th century. Simon Stevin was the first expert to write about decimal fractions. He also wrote about statistics and hydrostatistics. Nicolaus Copernicus wrote a theory about the universe which was completed in 1530 but published only in 1543 after his death. He wrote trigonometric fixes. Joachim Raiticus, a student of Copernicus from Germany for 12 years, he complete a trigonometric table of the 6 trigonometric functions in second intervals. The first scholar, Raiticus, defined trigonometric function expressed by the sides of a right triangle. Table Raiticus was published in 1593 by a German priest who was interested in mathematics, namely Bartholomaeus Piticus. It can be concluded that at the end of the 16th century, the development of mathematics had already laid the foundation for its further rapid development in the 17th century. Okay, next, mathematicians in Europe in the 13th until 16th century. There are first René Descartes. René Descartes, also known as Renatus Cartesius, in Latin literature for his work on creating the Cartesian coordinate system. René Descartes lived in an age of change, just like the world today too. The period when Descartes lived was a time when new ideas about science, mathematics, philosophy, and literature were created by intellectual giants such as Newton, Galileo, Fermat, and Shakespeare. While he was camping in a small village on the Danube, a big idea appeared in his dream. In his dream, he saw how algebra could be applied to geometry. This shock opened up an entirely new field of mathematics, now called analytical geometry, which has become one of the most widely used mathematics by scientists to study natural phenomena. Number 2, Isaac Newton. In the field of mathematics, Newton, together with the work of Gottfried Leibniz, which was done separately, Newton developed integral calculus. He also success in elaborating the binomial theory, developing the Newton-Smith method for approximating the zero value of a function and contributing to the study of power series. Okay, next, number 3. Leonhard Euler. Leonhard Euler is a mathematician who produced the most discoveries of all the time. In the 18th century, Euler was responsible for much of the notions in use today. Euler is also remembered for his work in the form of closed curve to illustrate the talk of the syllogism. This diagram is known as the Euler diagram. Number 4. Carl Friedrich Gauss. Carl Friedrich Gauss considered himself the prince of mathematicians and says mathematics as the queen of science. One of his work is that he published the book Disquisitions Arithmetic, which is the most influential number theory of all the time. Next, Gottfried Wilhelm Leibniz. Gottfried Wilhelm Leibniz was a universal genius, an expert in law, religion, philosophy, literature, politics, geology, history, and mathematics. And next, number 5. Augustin Louis Cauchy. Augustin Louis Cauchy was born in Paris. During his career, he served as a professor at the École Polytechnique Sorbonne and Collège de France. One of his work was that Cauchy developed Euler's formula for plane geometry by writing the sum of angle or S, surface or M, vertex or V, or a polyhedron S plus 2 equals to M plus V. 6. Fibonacci. In 1202, he published the book Liber Abaci using Hindu-Arabic numerals. Okay, I think that's all from me that I can explain about the topic Europe mathematics development. If I have a mistake, I apologize. I hope I will be better in the next chapter. If there are critique or suggestion, you can write them in the comment column. Hopefully, this explanation video is useful for you. Thank you for watching and see you next video.